Our dear students and subscribers, welcome back again to solving numerical problems on engineering mechanics. In the last video, we learned about moments and their applications. We studied Bergman's theorem, moment center, moment arm. And let us do a numerical problem. Problem set 2.6, solution to 2.81. As you can well see in the diagram, the picture given in the book, here is a piston. This is the connecting rod connecting with the piston, movable piston. The piston moves up and down. And here is your crankshaft. As this piston moves up and down, some axial force is developed in this connecting rod and is transmitted to this point. And here, that force will have two components, rectangular components. One will be to this side and one will be to this side. And the one that is perpendicular with the crankshaft will produce a turning effect about the moment center. This will be your moment center. So let me read out the problem first. If the piston of an engine in figure A has a diameter 101.6 millimeter, means from here to here, from this length, from here to here is the diameter of the piston, that is given as 101.6 millimeter, right? And the gas pressure, look, there is gas inside it. In the cylinder is 0.69 megapascal. Calculate the turning moment M exerted on the crankshaft for the particular configuration shown here. Now, before you do this numerical problem, I would suggest you should go to solution 2.14 of problem set 2.1, where I have discussed the various parts of the crankshaft, the connecting rod, and how it operates. Then come back here. And the piston, I have redrawn it here. Now, since there is a pressure inside the gas, 0.69 megapascal, and there is an area of cross section. There is a diameter, so there is a radius. So pi r square will be the area of cross section. And we know force exerted per unit area is nothing called pressure. So force is equal to area times pressure. So P remaining same, if you can increase the area, you can apply more force. So the same piston diagram is redrawn here. As this piston, this black portion, moves up and down, the pressure changes. The pressure changes means the area of cross section remaining same, the force also changes. So what is given is the length of the connecting rod, that is from here to here is 380 millimeter. We will not require this. And the length of the crankshaft from here to here is 178 millimeter. This angle is given as 90 degree. So since AB, what is given from this point to this point, I name it as AB. The connecting rod AB given as 380 millimeter. Then from this point to this point, from the moment center to the point where the connecting rod is connected with the crankshaft at point B, this length OB is given as 178 millimeter, that is the length of the crankshaft. D is the diameter of the piston, that is from here to here, that is same thing as from here to here, 101.6 millimeter. So the radius will be of obviously half of the diameter, so the radius is d by 2. So area of cross section for a circular one will be pi r square. pi r square, and since we know pressure is equal to force exerted per unit area, force by area, so your force will be equal to, have a look at the diagram, redrawn diagram again. I will tell you what these black lines are. The axial compression force developed along the connecting rod. So your force, by cross multiplying this, your force becomes pressure into area. Pressure is given as 0.6 megapascal. So I multiplied this with 10 per 6 to convert this to pascal. Pressure, area pi, radius r by d by 2, square of that. So this is your force. Now this force is transmitted. Normally to the area of cross section of the piston. Now the force is transmitted normal, means along this line. So due to this connecting rod AB will be compressed, will try to compress. So there is an axial force, compression force, that will be developed like this towards point A and also towards point B. So let us first find out this, how much is this force. Let us find out this, how much is those force, and what compression force is transmitted along the connecting rod AB. Then we will solve the problem. Now, since D is given as, diameter of the piston is given as 101.6 millimeter, so I convert it to meter by multiplying with 10 to the power minus 3. So force, which I explained to you here as 0.69 10 to the power 6 pi square of the radius. Now I put the value of D by 2. So your force becomes 0.69 10 to the power 6 pi. This is your D by 2, square root of that. Because D was given in millimeter, I have converted to that meter by multiplying with 10 to the power minus 3. So when you put all these things in a scientific calculator, this comes out to be 5594.05 Newton. And this is not correct. 5594.05 Newton. They have rewritten here. Now, as I just explained, AB is the connecting rod. AB is the connecting rod, and your BO is the crankshaft. As the piston moves up and down, this connecting rod, and there is a axial force developed in it, let it be S, which will be to this side for point A, it will be to this side for point B, and a part of that force, that is S cos alpha, will be perpendicular to the crankshaft. So the crankshaft will have a turning effect about the point O. Now let this angle is alpha. We are not required to find it out. So this axial force S, which I can represent here in this direction, then this vertical line is parallel to this line, and since this angle I have taken as alpha, so this will be alpha. So the component of S to this side will be S cos alpha, and the component of S to this side will be S sin alpha. S sin alpha, the line of action of S sin alpha passes through the point O. So S sin alpha will not have a turning effect about point O, whereas S cos alpha will have a turning effect about point O, because the line of action of S cos alpha is at this perpendicular distance, 178 millimeter from here. So this will have a turning effect on the crankshaft about the moment center O. So that is what I have explained in words. AB is the connecting rod connected to the crankshaft at point B. And the above force, the force we just calculated, F, as 5594.05 Newton, is acting on the piston normally. that is to be understood. This force F is acting on the piston normally along this side. Now, due to which this force F will develop an axial compression force S in the rod AB, the connecting rod AB. This F, which is acting normally like this, will develop a force of compression in the connecting rod AB, and that I have represented as S. So, since it is a rod, it is not a string, so it will be pointing towards the point A. It will be pointing towards the point B also. So, this force F develops an axial compression force S in the rod AB. So, now look at the point A. Now, at point A, there are two forces. Here at point A, there are two forces, the force F and the axial compression force S along the rod AB. There are two forces at A. So, which I have shown it here. The force F due to the pressure in the piston, and this is the axial compression force S in the connecting rod AB. So, what do I do? This angle is alpha I have taken, so I can shift this S parallel to itself and show it here, and I can transmit the line of action of this force F little downward and show it here. So, if you apply sigma y is equal to 0, if you drop a perpendicular here on y axis, this part from here to here will be your S times cos alpha, that will be equal and opposite to F. No need to calculate alpha. So, S cos alpha is equal to your F. So, so take cos alpha to the right hand side. So, axial compression force S is equal to F over cos alpha, which acts towards the point B also. So, now look at the point B. Now, look at the point B. The same axial force S is acting towards point B also. So, at point B, I resolve S into two rectangular components, S sin alpha, S cos alpha. S sin alpha is along the same line. The line of action of S sin alpha passes through the point O. So, this does not have a turning effect for the crankshaft about O. Rather, S cos alpha has a turning effect because S cos alpha has a perpendicular distance from point O. So that is the final part of it. Now let us go. So at B, S has two rectangular components, S sin alpha, S cos alpha. At point O, the norm called the moment center about which the crankshaft is rotating. Therefore, S cos alpha at point B will have a turning effect about O, but not S sin alpha, as I just explained, because S sin alpha, the line of action of S sin alpha, passes through the moment center. So, this does not have. So, S cos alpha has a turning effect. And as we have discussed in previous video, moment of a force about a moment center is the product of the force and length of the moment arm, and this was given in millimeters. So for S, which I calculated as F over cos alpha, this cos alpha remains as same, cos alpha cancels. So F times 178, and F was already calculated 5594.05, 178 millimeter. I convert that to meter. So all these things now in SI units. So if you multiply with a scientific calculator, this comes out to be 995.7409 Newton meter. Force into perpendicular distance. So this is nearly 1 kilonewton, nearly 1000. So 1 kilonewton meter is the torque, is the turning effect applied, developed at the moment center O due to the pressure 0.69 megapascal developed in the piston. means pressure converted to force, then force converted to axial force, compression force along the connecting rod, then which part of that axial force is producing turning effect about that is found out. Then the turning effect is found out by the product of the force and the perpendicular distance. That is all about. So I hope you are doing well and enjoying those videos. If you like it, if you can give a thumbs up, pass on to your friends. Feel free, like you can give your comments also. Thank you.